A girl on a sledge is moving down a snow slope at a uniform speed. Okay. Draw the free body diagram for the sledge at the position down on the snow slope. Somewhere here, what is the free body diagram? Free body diagram here tells you there's a normal force acting here because she's still on the surface, and there's a weight which is acting downward like this, mg. These are the only two forces that we can put across, mg, normal force, and with a uniform speed. There's a reason here, uniform speed. So whenever something comes down a slope, they should be accelerated. But when you say uniform speed, there should be a friction also acting like this. Friction here. Okay, so three forces should be very clearly given over here. Then, next one. After leaving the snow slope, the girl on the sledge moves over a horizontal region of the snow. Explain with reference to the physical origin of forces why the vertical forces on the girl must be in equilibrium as she moves over the horizontal region. Okay, so why should the vertical forces be in equilibrium? Well, let us say when the girl is at this point over here, normal force should be here, mg force should be here. They should be in equilibrium because there is no vertical movement over here. She doesn't fly off from here. But what is that you should write over here? You should write, this is for 3 marks. The first one is mg and n act opposite to each other. Opposite to each other, 1 mark. They are equal and hence cancel. This implies net force vertically is equal to 0. 1 more mark. And finally, vertical equilibrium is C. Okay, that's what you can say. So this is your 3rd mark. Next. When the sledge is moving on to the horizontal region of the snow, the girl jumps off the sledge. Okay, so this is the snow, so she moves on to the horizontal, and somewhere over here she jumps from here. Okay, the girl has no velocity after the jump. Okay, the velocity of the sledge immediately after the girl jumps off is 4.2 meter per second. So let us say the girl is somewhere over here and the sledge is now moving at 4.2 meter per second. The mass of the girl is 55 kg, so she is 55 kg and the mass of the sledge is 5.5 kg. 5.5 kg. Okay, 5.5. Okay, the calculate the speed of the sledge immediately before the girl jumps. That means what? So when you have in this position, when this is the sledge and this was the horizontal position, the girl and the sledge were together, then what was the velocity as compared to at this position? Now what is this? This is nothing but explosion, right? In explosion, what happens? You have a single entity, then suddenly after some time during explosion, so it breaks up into two entities and comes out. In a similar way, see, one entity is here, the other part is over here. So here they were together. Which rule will you apply? You will apply conservation of momentum, right? Conservation of momentum could be applied in the two situations. You can apply it during collisions. You can apply it under explosions, right? Both of them you can apply. And the only condition for this to be true is that no external force acts. No external force acts. Okay, this is what is the condition. So towards it. Now here what is happening over here? So what is the total mass of the girl along with the sledge? It is 55 plus 5.5. Both of them are moving with a velocity v. Now after the jump, what is the velocity of the sledge? Velocity of the sledge here alone is seen to be 4.2, mass of this 5.5. So momentum here is 5.5 multiplied by 4.2. And what is the momentum of the girl? Moment of the girl is 0. So therefore we can equate this one here. 55 plus 5.5 should be 60.5 times v should be equal to momentum of the girl, which is 0, plus momentum of the sledge alone after the explosion is 5.5 into 4.2. 5.5 into 4.2. Find the value of v. So let me use my calculator. Where is my calculators here? Right, so this will be 5.5 star 4.2. I get this as 23.1 divided by 60.5. When I do this, how much do I get? Divided by 60.5, I get this as 0.38. So the velocity of the sledge alone after the girl jumps from it is seen to be 0.38 meters per second. Let me just check whether my answer is correct. Yes, that's 0.38 meters per second. Then The girl chooses to jump so that she lands on the loosely packed snow, than on frozen ice. Choose why should she choose why she chooses to land on the snow. What is the reason for it? See, generally when we are moving, okay, and if we want to jump from a cycle or something like this, what we do is we look at the sand instead of a rock. What's the reason? A rock is nothing but like ice. Okay, ice is very hard, and snow is like sand. When you jump on snow, what happens? There's a resistance being given to you, right? It takes a long time for you to come to stop. Okay, so therefore, what will you write over here? So you will write something like change in momentum. Change in momentum takes a long time. It does not immediately change, right? So therefore, when the change in momentum takes a longer time, what is the consequence of it? Consequence is the impact felt is less. And as a result of it, now what is it? So injury if any on snow after you fall, because whenever you fall from any moving vehicle, definitely there will be a lower injury. But if it is lesser, so it will be lesser here. If any on snow will be lower than that on ice, right? So 3 points we have very clearly mentioned over here. Okay, next. The sledge without the girl on it now travels a snow slope that makes an angle of 6.5 degree to the horizontal. Now what is happening over here? This was a sledge, this was the slope that the girl had come across. This was a straight line, and after that the sledge is moving across this line over here. So this is making an angle of 6.5 degrees. Okay, so she jumped from here, the sledge is now trying to move upwards like so here. Okay, at the start of the slope, the speed of the sledge was 4.2 meter per second. Okay, when it came here, the speed was 4.2 meter per second. So what will happen? After some time, it will go and stop here, right? The coefficient of dynamic friction of the sledge of the snow is 0.11. See, without gravity itself, it will stop. If that is the case, without friction itself, it will stop. Now with friction, definitely it has to stop. So it will stop at this point. The value of mu is given to you as mu is equal to 0.11. Show that the acceleration of the sledge is about -2, which is what there is a deceleration. Okay, let us look at that also. So what will happen over here? So how do we solve this? What are the forces acting over here? The forces acting here is nothing but, see, this is your normal. Let me write down a separate figure to make it more clearer. Okay, so this is my 6.5 degrees. This is the object over here, sledge. This is your normal. Then this is your frictional force. First write down what is frictional force. Frictional force should be equal to mu times n, right? And what is n here? N is nothing but this is your mg cos 6.5 degree. So therefore n is equal to mg cos 6.5 degrees. So this should be mu times mg cos 6.5 degrees. This is the frictional force acting backwards, right? Opposing the motion of the object. Then at the same time, when the object is going upwards, gravity is also trying to pull it like this. What is that force? That force is mg sine of 6.5 degrees. What did I do? I divided this. I took this force and I resolved it into x and y components, and that's why I got this value, right? So therefore, the another downward force is nothing but gravity. Let me write Fg is equal to mg sine 6.5. mg sine 6.5. So therefore, at one point, now as it keeps on going over here, the total force acting on it is nothing but this plus this, right? F total is equal to, what is mu? 0.11 times cos of 6.5 plus sine of 6.5 multiplied by mg. Now what has been asked? Acceleration of the slope has been asked. Okay. Now we have all this value. Now what is this Ft? Ft is nothing but total force, right? M into A. Okay. M into A is equal to whatever is given here, multiply this by M into G. This M and this M goes away. So you get the value of A here directly. Thus A is equal to, let us calculate what is the value of A. So the value of A would be, I take the calculator. Now I get this as 0.11 cos of 6.5. So where is cos of 6.5? Let me take trigonometry here. So take, oh my god, just a minute. So I should first write 6.5 there, 6.5, and then take trigonometry and take cos of 6.5. You get 0.99. Okay, so I will now write this as 0.11 multiplied by 0.99 plus 0.9935. 0.9935 plus, or maybe I'll take the product of this, star 0.11 is equal to how much? Is equal to 0.11, 0.109. Okay, let it be, plus what is this value? This value is mg sine 6.5. What is sine 6.5? Once again, 6.5, and then you take the sine value of this, sine value, which is 0.1132. I'll write down this also, 0.1132, right? Multiplied by g here. G is there outside. So when I do this value, how much do I get? I get this as 0.9935 into 0.11 equal to so much, equal to so much, plus 0.1132. When I do this, I get so much. Now this multiplied by 9.8 or 10 over here will give me around 2.22. Okay, so 2.22 meter per second square, which is closer to -2. I should get a negative here because it's been dragging downwards, so this should be -2. If I hope, maybe if I had taken 9.8 over here, let me try it out using this also. I first divide this by 10 so that you get only that inside the bracket quantity. Multiply this by 9.8 so that I get 2.18, which is closer to this. Okay, thus we have got the right answer. Now let us move on to the next one. Calculate the distance along the slope at which the sledge stops moving, assuming that the coefficient of dynamic friction is constant. Now what's the question once again? So this was the flat part, this was the slope part, and the sledge stopped over here. So he's asking you, what is the distance moved by this in this direction? There is a question. Now how do we do? What is the energy here? The energy here was nothing but half mv squared, right? This energy was given to it so that it can climb over here, right? So what we do is, so the work done by the sled to start from here and to come here is nothing but F into distance, right? So we already know what is this F. What is this F due to? F is nothing but the frictional force over here. What is that we have got here? The frictional force plus the gravity force. Okay, so and then this should now be equal to difference in the kinetic energy, work energy theorem. Work done should be equal to difference in kinetic energy, which should be equal to half mv square, right? So therefore now what we should do, I need to get the value of F here. Now I already know the value of A here. F I can write this as m into A. M into A multiplied by S is equal to half mv square. I'll just take the magnitude of this. This m and this m goes away, and I only have A. What is this A here? 2.22. 2.22 multiplied by S is equal to v square. What is v square? The velocity at this point. What was the velocity at that point, at the beginning point? The velocity at that point was seen to be 4.2, right? So I'll write this as 4.2 square divided by 2. Okay, so therefore S should be equal to 4.2 square divided by 2 into 2.2. Okay, when I do this, what is the answer I get here? So this should be, cancel this, 4.2 star 4.2 divided by 2 is equal to so much divided by 2.22. I get the answer is 3.97. 3.97 meters are nearly 4 meters. So what is my answer? 4 meters. Okay, I get the answer 4 meters. Okay. Okay, now the coefficient of static friction between the sledge and the snow is 0.14. Okay, outline with the calculation the subsequent motion of the sledge. Now as you see, previously also this value of mu was given. What was the value? 0.11. Friction was 0.11. Suddenly they have increased it to 0.14 now, which means he is asking you, if 0.11 was there, then this is what has happened. If it is 0.14, which means what? The frictional coefficient is increased. Then what can happen? There's a question over here. Okay, so now what do? We can now write frictional force as a result of it would be mu times n, which should be 0.14 times mg sine 6.5 as a cos 6.5. Cos 6.5 right? Which should now be equal to 0.14 into 5.5 kg multiplied by 10 multiplied by cos of 6.5. So when I do this, what's the answer I get? I just get this as 0.14 slash 5.5 slash 10 slash, I do one thing, I'll just find out what is this now. This is 7.7. I want to find cos 6.5 separately. I cannot do it directly here, so I will make 6.5 and then cos of 6.5. I get the answer 0.9935. okay, so this multiplied by 7.7 will be 7.65. so you get the answer here as 7.65 Newton. Now let me compare this with the old one, whatever we have got earlier. So what was the frictional force earlier? We got something like 0.11 into 0.9935. Let us do that also. 0 point earlier. So let me write FF earlier is equal to 0.11 star. What was the value? 0.9935. 0.9935. When I do this, I get 0.109. I need cos 65 completely, right? Multiplied by m into g. I just got the g value, only this value, multiplied by m into g. Multiplied by m into g would be multiplied by m is 5.5 kg multiplied by 10. I get 6.01. I get around 6.01 Newton over there. Now the frictional forces increase. So what could be the conclusion here? Because, okay, now it's a 2 marks. You can say because frictional force has increased by 1.65 Newton. Distance traveled by the sledge will be less than 4 meters. Less than 4 meters. You can write like this. Okay. So with this we come to an end to this particular problem. For 17 marks we have taken more than 17 minutes, but anyway the problem was good enough to solve this. Okay, let us see the rest of the problems in the next session. Thank you.